What we will study? We will study chemical reactions, chemical equations, and types of chemical reactions. The first question that comes to our mind is why we study chemical reaction. Before I introduce you the actual definition of chemical reaction, let's look into the real life scenario of chemical reaction. You have this food, you keep this food in a room temperature for, let's suppose, 30 days, right? After 30 days, it smells. You feel that? You'll feel the smell coming out, right? Everything gets rotten, right? This get rotten fungus comes here. This smells a lot. Why this smells? Because there is a reaction that happens in the food and the smell is produced. So this is because of a chemical reaction that happens in the food if you keep the food for a long time. The medicines which you take, these medicines have some reaction in your body and then you feel better. For example, if you have a headache, you take some medicines and then after some time you feel better because these medicines react with your body and create some effect. If you see this tree, how it derives food is, it takes this light, it takes the sunlight, it takes the chlorophyll it has and then it produces food for its own, right? So if you see, this is also a reaction. Photosynthesis, if you have learned in your biology classes, I think, right? So it says that this is nothing but a reaction, a chemical reaction that happens where you have this light and chlorophyll and then which produce, the plant produce food. This is also one example of the chemical reaction. We breathe air, right? We breathe air and this air is used for survival. How? This food which we eat, on that we add oxygen and we get energy. And this oxygen we get from respiration. But if you see, this is also a chemical reaction. You have food, you take oxygen and you add, you get energy. This is an example of one chemical reaction. If you see the batteries, the lithium battery or zinc battery which works, is a chemical reaction happening at the positive end, at the negative end. Here oxidation and reduction happen. We'll tell you what oxidation and reduction is. Just understand that some chemical reaction happens and that chemical reaction produces the electrical energy in the battery also. If you see the iron thing you have, after some time it gets rust. And this rusting is nothing but a reaction. So we have an iron reacts with oxygen and it produces the rust, right? You have any iron substance you keep in outside your home for 10-20 days, you will see that things got rusted. So this is also one chemical reaction that happens. The food we eat is digested. How it is done? This body produces hydrochloric acid and this takes the food and it digests the food. So this everything is nothing but a chemical reaction. The digestion of food is nothing but a chemical reaction. The car which you drive, in the car we put diesel or petrol depending on the car variety you have, or petrol, or sometimes now people use LPG gas also, right? Or CNG gas if you are living in Delhi. So whatever fuel we use, that fuel burns and produce energy. So this is also nothing but a reaction that happens, right? You have the car, in the car you burn this diesel, petrol or gas, it gives energy. So this is also one reaction, correct? Also it generates heat. It generates heat also in this case. So what you observe in all these cases, right? Sometimes we get heat as output, sometimes we get some smell. Sometimes the state is changed. For example, this was looking good, but after some time the state got changed, right? State changed. Here also state changed, right? So sometimes there is a state change, sometimes you get the gas out, sometimes you get the heat, right? So all these things are characteristic of a chemical reaction. So we observe that the change of state happened, the color happened, the change in color happened, the evolution of gas also happened in some case, and the temperature also changed in some of the cases. So this is what we observe in the initial substance when the initial substance went for a chemical reaction. So before we even define chemical reaction, let's have some activity of chemical reaction. So what I'm doing is I'm taking a clean magnesium ribbon around 2 centimeter long, right, and I clean that with sandpaper to make sure that there is no dust or something, and I hold with a pair of tongs. So burn this using a spirit lamp and collect some ash. For example, this was my magnesium ribbon, 2 centimeter long. First I removed all the dust using sandpaper, and now I'm holding this, I'm burning this with a spirit lamp, and all this dust which I'm getting, right, I'm collecting this in a ball. So what you see this guy, this magnesium ribbon, this burns with a dazzling flame. This burn with a dazzling flame, right? This some flames comes out, dazzling flame, and this change into white powder. This powder, if you see, is a white in color. This is a white powder, if you see, right? This is a white powder which you get here. Correct? So the reaction, if you see here, is there was a magnesium there. This guy is a magnesium. Oxygen you got from surrounding air, plus there was some heat required. Actually, there was a heat required. You added some heat and you got magnesium oxide. This is one chemical reaction. If you see, I'm just repeating it here. In this scenario, what we have seen, that there's a magnesium ribbon that got oxygen from the surrounding, because we didn't add anything to that. We just had a magnesium ribbon. We heated it up. On heating, we got magnesium oxide, because this thing, white powder, is nothing but magnesium oxide. So we already know what magnesium is. We have fair understanding of all the elements little bit, and we will have more understanding in class 11 when we learn again. In fact, in the same class itself, where we'll learn the periodic table. So magnesium is the element. When you combine with oxygen, you get magnesium oxide when you heat this. So this is the example of a chemical reaction that happened where magnesium was converted to oxygen. So what is the chemical reaction? Whenever a chemical change occurs, please note, whenever a chemical change occurs, we say that chemical reaction has taken place. In this case, the magnesium was converted to magnesium oxide. Correctly, this is the definition of chemical reaction in the world of chemistry. Example, magnesium plus oxygen in presence of heat converted into magnesium oxide. So initial chemical was magnesium and oxygen that got converted to magnesium oxide. So the chemical change happened in this case, so we call this guy chemical reaction. So chemical reaction typically has reactant and products. For example, the reactant is nothing but the substance that undergo change, and product is nothing but the new substance that is formed. For example, in this case, my magnesium and oxygen is something which is undergoing change, right? So they are reactant. A magnesium oxide is the final output. So this guy is a product, and they are separated by a line. Because this is a chemical reaction, we'll write a chemical equation for the same thing, and I'll tell you why we'll write a chemical equation. So magnesium and oxygen react to form a product called magnesium oxide. This is a typical example of chemical reaction where you have a reactant and product, where reactant is converted into product. Why do we need chemical equation? Till now we have learned chemical reactions, right? Till now we have done we know what is chemical reaction, where some chemical change, we have reactant and product. Now we are learning chemical equation. Why do we need chemical equation? The first thing is, instead of using magnesium, oxygen and all, we can use the short form of that, right? Also we can use short form. Also we can balance it. Balance it by, because the law of conservation of mass says that you can't create, you can't destroy mass. So if you have one magnesium atom here, it has to be one magnesium atom here also, right? Yeah, if you have So let's suppose 2 oxygen atom, then you should have 2 oxygen atom here also. So those kind of balancing we can do if we have a chemical equations. Also, we use a short term of the name. So it's the same thing. When you say magnesium plus oxygen, you have magnesium, you have oxygen, it gives magnesium oxide. This is nothing but a chemical equation, right? So chemical equation, you can write this is my reactant, this is the product. Also we can write what is required. So in this case heat is required, so just above the arrow we can write the condition that is required to produce the output. This is a typical example of a chemical reaction. You have the reactant, you have product, chemical equation, and then you have this extra conditions required, right? For example, you have a more scenario. So we have carbon monoxide plus hydrogen, both were gases, and we provided some 340 atom, we got CH3OH, and this is the liquid in shape L. So I'll explain you what all these LG means. For example, we have carbon dioxide with water, and we pass this with sunlight and chlorophyll. This is nothing but a photosynthesis process. We have carbon dioxide and water and sunlight and chlorophyll. You get this, and this is the aqueous solution plus oxygen you get, which we breathe, right? We say that tree take carbon dioxide, and trees give oxygen, right? This is what happens in tree. This is the process of photosynthesis actually. So where what happens is the tree takes carbon dioxide, tree takes water, which we give water to the tree. In presence of sunlight and chlorophyll, only in days tree produces oxygen and chlorophyll, it produces this substance, and this is nothing but the food for, this is the food for tree, right? So this is a typical example of chemical equation where we write everything in the short form, right? Also we write the state of this. For example, this is aqueous, this is a liquid, and this is gas. So I'll take you through the states of chemicals in the typical chemical reaction. Aqueous solution is something which is dissolved in water, right? This is coming from the word aqua. For example, you take salt, the common salt which you use, NaCl. This is actually, if you see, it's a solid thing, right? It's a dry, the solid thing. But the moment you put in water, this becomes a aqueous solution. Correct? This becomes an aqueous solution. So why? Because NaCl, if you see, is nothing but Na plus and Cl minus ions. There's an ionic bond. We'll explain all these bonds in the later chapters. So the bond breaks, and in the water, this Na plus and Cl minus, this bond, this flows actually. You have this water, you have this Na plus, Cl minus, this thing flows actually in this. And this is aqueous solution because this is a partially dissolved thing. It's an aqueous kind of stuff. Liquid is total liquid, for example, water or any juice, it's all liquid. Insoluble is insoluble solid is you get the actual solid. For example, iron is a solid, right? Iron is a solid. Copper, zinc, gold, silver. These are all solid because they don't dissolve in water. And then you have gas. Gas, you know that it has fumes and all those things are gas. So you have 4 states typically. Solid, liquid, gas, I think you're aware. Aqueous is nothing but, you can say that some substance that is partially or that is dissolved in water is called aqueous. It's in dissolved state. So the basic principle of a chemical equation is it should be balanced, because the law of conservation of mass that we have studied in class 9 says that mass can neither be created nor can be destroyed in any chemical reaction. So you can't neither create nor destroy, right? You can't create or destroy any element in any chemical equation. That is, the total mass of element present in the product of chemical reaction has to be equal to the total mass in the reactant. So this guy is a reactant, and this guy is a product. So mass has to be same, right? So you're talking about the reactant. For example, this guy has, let's suppose, 5 oxygen, 3 hydrogen, and 8 nitrogen. Let's suppose some equation. Here also it should have similar number of oxygen, hydrogen, and electron. It has to be balanced. And that is what the law of conservation of mass says, right? That is, the number of atoms of each element remains same before and after a chemical reaction. This is a very critical thing that you should know, that the law of conservation of mass says that you can't create or destroy mass, so that for any chemical reaction, the number of elements of any atom, number of atoms of each element has to be same before and after chemical. For example, if you see this guy is my reactants and this guy is my product. So here if you see, magnesium is how many? Magnesium is 2. Here also magnesium is 2, 2 into Mg. Oxygen is 2, O2. Here also oxygen is how much? 2 into 1, that is 2. So if you see that magnesium and oxygens both are 2. Here also we will take one more example. You add zinc to H2SO4 sulfuric acid, you get ZnSO4, zinc sulfate and hydrogen gases. So here also if you see, the zinc element in reactant is 1, product also 1. The sulfate count in reactant is 1 and product is 1. The hydrogen count in reactant is 1 and product is 2 and product is also 2. So this is also a balanced chemical equation, right? Any equation has to be balanced. So we'll do some exercise on the balanced chemical equation. We'll take some equations and we'll find out if it is balanced or not. So the first equation is zinc plus H2SO4 is equal to ZnSO4 plus H. So let's see if it is balanced or not. So you have this reactant and you have this product. So in reactant you have zinc. How many zinc? 1 zinc. In product, how many zinc? 1 zinc. Zinc is balanced. Let's take sulfate SO4. It's a compound actually, so we'll take this in one go. So SO4 is how much in reactant? 1. Product is how much? 1. Correct. Let's take H, hydrogen. Hydrogen reactant how many? 2. In product how many? 1. So it is not balanced. It is not balanced. So this guy is not balanced. To make it balanced, you have to make it H2. Then only it will get balanced. If it is not H2, it is not balanced. Let's take this example. Fe plus H2O is equal to Fe3O4 plus hydrogen. So here also we have, let me write here, iron, hydrogen and oxygen. 3 molecules we have in reactant and we have in product. Number of iron molecules in reactant is 1, in product is 3. So we see iron itself is not balanced, so we don't need to find other things. We can say that it is not balanced because the iron itself is not balanced. We'll take carbon monoxide and hydrogen, we'll get this. So we'll see if it is balanced or not. So in this case we have carbon, hydrogen and oxygen. So we have this reactant and product. So carbon we have 1 here. In product also we have 1. Hydrogen we have 2 here and product we have 3 plus 1, 4. So we can say that this guy is also not balanced. Correct. Let's take one more example. Carbon dioxide plus water is equal to this food of tree plus oxygen, then this happens in presence of sunlight and chlorophyll. Right. So if you see here, this has carbon, hydrogen, oxygen, right? So in reactant and we have product. So in reactant we have how many carbons? 6 carbons. In product how many carbons we have? C6, that is 6 carbon, right? So if it is 6C or C6, both are 6 carbon, right? Hydrogen, how many hydrogen we have? 6 into 2, 12. Here we have H12, that is 12 hydrogen. Oxygen we have 6 into 2, 12 plus 6 into 1, 6. 12 plus 6, 18. Here we have 6 plus 12, 6 into 12, 18. So if you see that they are all balanced. So we have seen some of the equations here are not balanced, but we are told that all the equation has to be balanced, right? Chemical equation. So how should we balance a unbalanced chemical equation? So here is the rule, the priority wise. First, balance polyatomic things, right? If exist. For example, SO4, OH, NO3. These are all polyatomic things. If it exists in, and also if this should exist both in reactant and product. We'll take some examples to explain that. So if such kind of thing exists in both reactant and product, first balance that, then balance metals, then non-metals, and in that also hydrogen and oxygen are supposed to be balanced last. Why? Because there are plenty of hydrogen and oxygen around, right? So we generally balance it last. And also if you get something in fraction, then make sure that you remove the fraction. That means, for example, you get something like this, 2 by 3 somewhere, right? So by 2 by 3 x plus y is equal to z. So you can't have like this. So you have to multiply everything with 3. So it becomes 2x plus 3y is equal to 3z. So something of that sort. You can't have a fraction kind of stuff. Also note the critical thing. You can't change the formula. So if you have the equation, you can't change it, right? For example, you say that H2 plus O2 is equal to H2O. You will say that no, let me make it 2. You can't change that. If it is H2O, it has to be H2. You can't change the formula, right? You can't change, should not change the formula. That is a critical thing here. Don't change the formula. You can add any number. For example, you can add 3 here, 2 here, 5 here, 8 here. Any number you can add to make sure it's balanced, but you can't change the formula. Let's take some example to balance a chemical reaction. So we have nitrogen plus hydrogen give NH3. Let's see if it is balanced or not. So the first element will go by priority. The first element we should go for is nitrogen, right? Because there is no metal, non-metal, nitrogen is there. But we told that the hydrogen and oxygen is the least priority. The second priority will be for the hydrogen. So first we'll try to balance nitrogen. So we'll see here nitrogen, hydrogen, right? So we'll see this is my reactant, this is my product, right? This is my reactant, this is my product. So number of nitrogen in reactant 2, in product 1. It is not balanced, right? That means I have to multiply this by 2. So you get 2, correct? So I have to multiply this by 2. So what you get is N2 plus H2 is equal to 2NH3. I told you we can't change the formula, but we can multiply by any number. This is my new formula now. Now let's check if it is balanced. Again, we have this nitrogen, hydrogen, reactant, product. So nitrogen, how many we have? 2 in reactant. Product, how many we have now? 2. Hydrogen, we have 2 here. And here we have 6. That means if you multiply this thing by 3, my things will be balanced. Correct? So I'll multiply this thing by 3. So what I get new formula is N2 plus 3H2 is equal to 2NH3. Now let's see if it is balanced. Nitrogen, hydrogen, reactant, product. So nitrogen how many? 2. Hydrogen how many? Nitrogen here 2. Hydrogen will see reactant 6. Product how many hydrogen? 6. So if you see that they are balanced. So this is my balanced chemical equation. So what I have done is, if you note, first thing I did was I found is there any compound element. There is no compound element in this case. Then I found any metal, no metal. Any non-metal, yes, we got nitrogen and hydrogen. Then we first tried nitrogen, hydrogen last, because I told that hydrogen and oxygen has the least priority. So this is my order of checking now. I took check nitrogen, hydrogen. It was not balanced. So there were only 2 nitrogens here and 1 nitrogen here. So I multiplied into 2 the product side, because product side only 1. I got this equation. Then again check here, nitrogen was balanced but hydrogen was not balanced. Here the reactant side had only 2 nitrogens, 2 hydrogens. So we multiplied this guy with 3. Then we check, yes, everything is balanced. Thus I got a balanced chemical reaction. Let's take one more example. CH4, the methane, plus oxygen is equal to H2O plus CO2. Now, is there any compound? No. Is there any metal? No. Non-metal? Yes. So we have carbon, hydrogen, oxygen. So hydrogen, oxygen is the least priority. The first will be hydrogen, carbon, and hydrogen, oxygen will be the next. So you can write CHO or COH, doesn't matter. So I'll write CHO. So first I'll check for carbon. So CHO I have to check. Carbon is, this is the reactant, this is the product. This is my reactant side, this is my product side. So in reactant side I have one carbon and product side I have one carbon. Carbon is balanced. Next check hydrogen. There are 4 hydrogens here. There are 2 hydrogens here. Correct. That means this is not balanced. So I have to multiply this guy with 2. Correct. So I will get 4 hydrogens. So let's multiply this. So the new equation I will get is CH4 plus O2 is equal to 2H2O plus CO2. Please note I am not changing this formula, but I am just multiplying this number. So what now I get is, I'll again write CHO, reaction product. Again I'll check the value count, the number of carbon, because it may change. So carbon is 1, product is 1. Hydrogen we have 4 here and we have 4 here. Oxygen we have 2 here and we have 2 plus 2, 4 here, right? So oxygen is not balanced. That means I have to multiply this guy with 2. So I'll multiply this guy with 2. So what I now get is CH4 plus 2O2 is equal to 2H2O plus CO2. Correct? Let's check if it's balanced or not. So we have CHO, we have reactant, we have product. How many carbon elements? 1 in reactant. How many carbon elements in product? 1. Hydrogen we have 4 here. We have 4 here. Oxygen we have 4 here. And we have 2 plus 2 4 here. So if you see, it is balanced. So this is my balanced chemical equation. Simple. Let's take one more example. We have C4H10. You burn this with oxygen, you get carbon dioxide. What? So this is an example of reaction. We'll learn this kind of reaction actually. This is an example of a reaction actually, where things, you burn things. So here you see, in this reaction, let's again see the priority. Is there any compound? No. Metal? No. Non-metal? Yes. The carbon will take the first priority. Hydrogen, oxygen will take the next priority, right? So CHO is my priority. So in this case, we'll see how many CHOs here. This is my reactant, this is my product. So in reactant side, we have 4 carbon, and product side, we have only 1 carbon, right? So this is not matching. So let's multiply this guy with 4, right? So you get 4. So let's see how much it is. It becomes C4H10 plus O2, that gives 4 CO2 plus H2O. Now let's again compare the numbers here. CHO, this becomes 4, and the product we have 4. The carbon is balanced. Next is hydrogen. We have 10 here. We have 2 here. Correct? So that means we will multiply this guy with 5. Let's multiply this guy with 5. So what you get is C4H10 plus O2 gives 4 CO2 plus 5 H2. Let's again compare. CHO, reaction product, carbon is 4, product carbon is 4, hydrogen we have 10, hydrogen we have 10, oxygen we have 2 here, and oxygen we have 4 into 2, 8 plus 5 is 13 we have. So here we have 2, here we have 13. So let's multiply by 13 by 2. Correct? So if we multiply by 13 by 2, C4H10 plus O2, 13 by 2 O2 is equal to 4 CO2 plus 5 H2. So what you get is, now if you compare CHO, reaction product, carbon is 4 and 4, hydrogen is 10 here, 10 here, oxygen is 13 by 2 into 2 is 13 here, here you have 4 into 2, 8 plus 5. Things are balanced, but the last rule says that there should not be any fraction, but here's a fraction here, right? So we'll multiply everything with 2 because it was divided by 2. It's 13 by 2, so let's multiply everything by 2 to make sure there is no fraction here. So this becomes 2C4H10 plus 13O2 gives 4 into 2 is 8CO2 plus 5 into 2 is 10H2. And this is my balanced chemical reaction. So here we have seen that the extra part was we got a fraction here and we were told that there should not be a fraction. So we multiplied everything with 2 and we got non-fraction part. Let's take one more example. We have AgNO3 silver nitrate plus MgCl2 magnesium chloride give AgCl, that is silver chloride, plus MgNO3 to magnesium nitrate. So we'll balance this. So again the same formula. Is there any polyatomic thing which is there in both reactant and product? So we see there is one polyatomic thing, but is this in reactant and product both? You have to check that. Yes, it is. We see NO3 is here also, here also. That means my first priority will be NO3. Correct? Why? Because this NO3 is there in both reactant and product, and there is a polyatomic thing. Second thing, let's check for any metal. Yes, we have two metals, Ag and Mg. So let's write Ag and Mg here. You can write Mg, Ag also, doesn't matter. So these are two metals. This is my polyatomic thing. And is there any non-metal? Yes, we have chlorine here. So chlorine is the last. Any other thing? No. Because this oxygen is covered as part of NO3. So this is one unit actually. We'll consider this guy as one unit. This guy also one unit. So that's all we have. So first let's balance the NO3 part if it is not balanced. So let's see. We have NO3, Ag, Mg, Cl. So we have reactant and product. So NO3 is how many molecules? 1. And product we have 2. Oops, it is not balanced. Correct? It is not balanced. So we multiply this guy with 2. So let's multiply this guy with 2. So what you get is 2 AgNO3 plus MgCl2 gives AgCl plus MgNO3 2. Correct? We multiplied this guy with 2. Now again let's check if it is balanced or not. So we have NO3, Ag, Mg, Cl. NO3 is 2 here, 2 also here. Done. Ag is 2 here and 1 here. 2, 1. Oops, it is not balanced again. Correct? This guy is not balanced. So let's multiply this guy again with 2. So you get 2 Ag. So what I'm getting next equation is 2 AgNO3. This I'll write same. Plus MgCl2 also write same. This becomes 2 AgCl plus MgNO3 2. Correct? Now let's again compare. You have NO3, Ag, MgCl. This is reactant, this is product. So NO3 is 2 here, here is 2, 2, 2. Silver is 2 here, 2 here, correct. Magnesium is 1 here, correct. Chlorine is 2 here and 2 here, 2, 2. So if you see everything is balanced, thus I can say that this is my balanced chemical equation. So what we have seen is, first we balance that polyatomic thing, then we balance metals, and then we let's take one more example. We have KClO3 plus KCl is equal to KCl plus O2. You have to balance this. So we'll see any polyatomic thing. ClO3 is a polyatomic thing, but it is not here. So we'll not consider this. Correct? Please note, here ClO3 was a polyatomic thing, but it is not there in the product thing. So we'll not compare this. We'll not consider this. Correct? So ClO3 is not considered. Any metal? No. Non-metal? Potassium, chlorine, oxygen, all. So oxygen will put in last because oxygen, hydrogen has least priority. So let's see the balance thing. KClO. This is my reactant, this is my product. Potassium is 1, 2, and product there is only 1 potassium. It is not balanced. Let's multiply this guy with 2. So what you get is K ClO3 plus KCl is equal to 2 KCl plus O2. Now let's again see it's balanced or not. KClO, potassium is 2 here, here also 2. Chlorine is 1 plus 1, 2, here also 2. Oxygen is here 3, here it is 2. This is not balanced, so we'll multiply this guy with 3 by 2. So let's multiply this guy with 3 by 2. So what you get here is KClO3 plus KCl is equal to 2 KCl plus 3 by 2 O2. Let's see if it is balanced now. KClO, potassium is 2 here, product also 2, chlorine is 1 plus 1, 2 here, product also 2 KCl, right? So 2 chlorine. Oxygen is 3 here, here also 3 by 2 into 2, 3. So it is balanced, but there is a fraction part, right? So when we remove the fraction part, it is by 2. We multiply everything into 2. So what you get is 2 KClO3, this becomes 2 plus 2 KCl is equal to 2 into 2 becomes 4 KCl plus 3 O2. And this is my balanced chemical equation. We'll take one more example. I'm taking more equations because the most critical part of the chemical equation. You should know how to balance the chemical equation. That's the foundation of the chemistry, you can say. So we have HNO3 plus COH2. It gives CaNO3 2 plus H2. This is one chemical equation. Even if you don't know about this compounds, it's okay. You should just know how to balance the chemical reactions. So yes, balance this. So here we have some compound. Is there any compound? Yes, NO3, NO3. So this guy is there in both reaction and product. So we'll take NO3 as a first priority. Then we'll take metals. No, non-metals. We have calcium. And then we have hydrogen, oxygen. So we'll say hydrogen, oxygen. Right. So now we'll check. This is my priority order. Right. Priority order. We'll check NO3 part. Reactant and product. So my reactant has 1 NO3, product has 2, it is not balanced, so we'll multiply this guy with 2. So what you get is 2H NO3 plus COH2 is equal to CNO3 2 plus H2. Please note here OH was also one polyatomic thing, but OH is not here. It's only in the reactant, so we didn't take OH, right? But NO3 is also polyatomic thing. It is there in reactant and product both, so we took NO3. Hope you understand this, that polyatomic thing has to be there in both sides to take that. So we got this equation. Now let's compare. So we have this NO3 CaHNO. NO3 is how many? 2 here. Reactant and product. Product also we have 2. It is balanced. Calcium we have 1. Here also calcium we have 1, right? 1, 1. Hydrogen we have 2 plus 2, 4, right? 2 plus 2, 4 here. Here we have 2 hydrogens. So hydrogen is not balanced, right? See, this part you can't take, this part is again gone. So 2 hydrogen here plus this again we can take, because this here we have not assumed as a polyatomic thing because this was not there in the product side, right? So we'll take 2 hydrogen from here, 2 plus 2, 4 hydrogens. Here we have 2 hydrogen. Please pay attention here. Since OH was a polyatomic thing here, but still we could not take this as one unit because this guy is only in reactant, not in product. So when we talk about hydrogen, we'll take hydrogen from this also, right? So hydrogen 2 plus 2, 4 here, and we have only 2 hydrogen here, not balanced. So we multiply this guy with 2. So what you get is 2H NO3 plus CaOH2 gives CaNO3 2 plus 2H2. Now let's check if it is balanced or not. You have NO3 C HO, we have reactant, then we have product. Reactant NO3 is here is 2 molecule. In product we have NO3 2. Calcium we have 1 here and we have 1 here, 1 1. Hydrogen we have 2 plus 2 4 here, and here we have 2 oxygen. So please note, we will not take this oxygen because this is already counted as part of NO3. We will not take oxygen in this also because this is already counted as part of NO3. But we will take this oxygen. Why? Because this OH we have not considered as the you can say polyatomic thing in the priority list because the product didn't have this OH. So we'll take OH from here, but we'll not take O from here. Please note once again, we'll not take oxygen from NO3 now. We'll not consider that because it's already counted for. But we'll take O from this because OH is not counted for, right? OH we didn't consider because OH was not there in the product side. So for oxygen we have 2 oxygen here, and here we have again 2 oxygen because this oxygen we won't count. We'll count only this oxygen. So we'll see that things are balanced, right? So this is my balanced equation. Hope you understand this. The trick was here was in this the oxygen we won't count because we have already counted this oxygen, but we'll take oxygen from this guy OH because we didn't count the OH. Let's take few more examples. We have NOH, sodium hydroxide, plus H2SO4 sulfuric acid give Na2SO4, sodium sulfate, and water. So we have to balance this equation. So we already know the names of these things. We have learned all these things in the past classes. We want to balance this chemical equation. So here also if you see SO4 is 1 unit here. Here also we have SO4. That guy is my first priority. Right? And do you have any metals? No. We have sodium, we'll take sodium. Then we'll take hydrogen and oxygen. This is my order of the priority. First we'll try to balance SO4 if it is not balanced. So let's check. So we have this SO4, NaHNO. So this is my reactant, this is my product. In this case we see that SO4 there is 1 and here also we have 1 and 1. It's perfectly balanced. Then comes sodium. Sodium we have 1 here and 2 here. Oops, it is not balanced. So let's multiply this guy with 2. So the new equation we get is 2NeOH plus H2SO4 is equal to Na2SO4 plus H2. Let's again compare the values SO4, NaHNO. We have reactant and product. So sulfate we have 1 here, 1 here, 1 1 each. Sodium we have 2 here, 2 here, 2 each. Hydrogen, so we have 2 hydrogens here plus 2, 4 hydrogens here. Here we have only 2 hydrogens, not balanced. So let's multiply with 2. 2 into 2 becomes 4, right? So what you get is 2NaOH plus H2SO4 gives Na2SO4 plus 2H2. Now let's again compare. This is SO4, NaHNO. We have this reactant, we have product. SO4 is 1 1. Sodium is 2 here, sodium is 2 here. Hydrogen is 2 into 1 2 plus 2 4. Here we have 2 into 2 4. Oxygen gone. So we have 2 oxygen here. This we won't consider because this we already considered as part of SO4. This also we won't consider. So we have only 2 oxygen atoms here. And here also we have 2 oxygen atoms, right? This is my balance chemical equation. Everything is balanced. Correct. We'll take a couple of more examples. NaCl, sodium chloride plus AgNO3, silver nitrate becomes AgCl plus NaNO3. So here silver is any compound, no. Metal, yes. Silver is the metal. Any compound, yes. There's a compound, man. There's a compound. NO3 is a compound. So we'll take NO3 first. Then we have metal. We'll take metal, Ag. Then we have non-metal, sodium and chlorine. First we will try to balance this guy as NO3, then we have Ag, Na and Cl. We are reacting this guy product, right? So NO3, how many NO3 here? 1. How many here? 1. 1, 1 balanced. Ag, how many Ag in reactant? 1. In product 1. Sodium, how many sodium in reactant? 1. In product 1. Cl, how many Cl in reactant? 1. Product 1. You see it is balanced. It is already balanced. So there is no need to balance this equation. Is already balanced equation. We don't do anything. It's already balanced. Let's take one example. Barium chloride BaCl2 plus H2SO4 sulfuric acid give barium sulfate PaSO4 plus HCl. Let's see. So we have SO4 thing here, both sides. So SO4 is my first priority. Then we'll take barium, is the second priority. Then we'll take chlorine, is the third priority. And here we see that some hydrogen is also there, right? So we'll take hydrogen as the fourth priority thing. We'll compare now. We'll see sulfate part. In reactant we have 1. In product we have 1. Sulfate is 1. Barium part. So next is barium. Barium we have 1 here, 1 here, balanced. Next is chlorine part. We have 2 chlorine here. Reactant product we have only 1 chlorine. Oops, it is not balanced. Let's multiply with 2. Correct? So what you get is now barium chloride plus H2SO4 gives barium sulfate plus 2HC. Now again let's see the balance part, SO4, Ba, Cl and H, right? My reactant is my product. So sulfate is how many? 1 here, 1 here, 1, 1 balance. Barium is 1 here, 1 here, balanced. Chlorine is 2 here, 2 here, balanced. Hydrogen part. So we have 2 hydrogen here and 2 hydrogen here. Correct? Balanced. Everything is balanced. That means it is my balanced chemical equation. It's my answer. Balanced chemical equation. Sulfuric acid is added to KOH, potassium hydroxide, I think. This gives you potassium sulfate, K2SO4 plus water. Now again, if you see, is there any sulfate compound thing? Yes, we have SO4 here, SO4 here. That's my first priority. Then we'll take potassium and then hydrogen and oxygen. Correct? So we'll see the potassium part. So we have 1 here, 1 here. It's all balanced. Reactant product. Second was the potassium part. There was only 1 potassium here. There's 2 potassium here. It is not balanced, right? So let's multiply this guy with 2 to balance it. So what you get now here is H2 SO4 plus 2 KOH gives K2SO4 plus H2O. Correct. Now let's again see the balanced part. Then we have SO4, K and H2O. Sulfate part is 1 here, 1 here, reactant and product. Then we have this next is potassium part is 2 here and 2 here, all balanced. Hydrogen part, 2 hydrogen plus 2 hydrogen. We'll take hydrogen from here because OH was a compound, but still it is not here, so we are not considering this, right? So hydrogen 2 from here, 2 from here, 4 hydrogen, and here we have only 2 hydrogen. Correct? Does not balance, so we need 2 more hydrogen here, so we'll multiply with 2. So what you get now here is H2SO4 plus 2 KOH gives K2SO4 plus H2O, 2H2O. Now let's again check the balance thing. SO4, KHNO. Sulfate is 1 here, 1 here, balanced. Potassium is 2 here, 2 here, balanced. Hydrogen is 2 plus 2 here, 4 here, and here also 4. Oxygen is 2 here, 2 here, and here also 2 oxygen. So if you see, everything is balanced, right? So this is also balanced equation. Let's take the last example of this balanced chemical equation. A little tricky, so please pay attention here. So we have PO4 PO4 both sides. So PO4 is my one compound. OH both sides. So we have OH also one compound. Then I'll take calcium. Then I'm left with hydrogen only, right? Correct, because this guy I took, this guy I took, calcium, hydrogen remaining. These are my order of priority. Correct. So first let's check if they are balanced or not. So we'll check PO4. PO4 it has only one, it has two. Correct, this reactant, this product. This guy is 1, this guy is 2. Correct, so let's multiply this guy with 2. You get 2 PO4 both sides. So what you get is 2H3PO4 plus calcium hydroxide give HOH plus Ca3PO4 2. Now again let's compare. So PO4 we have 1 into 2 here. Here also we have 2. So PO4 is balanced. Now we'll see the OH part. OH part we have 2 here reactant. In product we have only 1. So that means this guy is also not balanced. So let's multiply this guy with 2. Correct. So what you get here is 2H3PO4 plus CaOH2 is equal to 2HOH plus Ca3PO42. Correct. Now let's again see PO4 OH CNH. So PO4 part if you see 2 both sides. OH part there is 2 here. Calcium part is 1 calcium here, there is 3 calcium here. Right? 1 we have 3. So we'll multiply this guy with 3. Correct, because it's not balanced. So what you get is 2H3PO4 plus 3CaOH2 gives 2HOH plus Ca3PO4. Let's again see the equations here. So again we have PO4, OH, Ca and H. So PO4 part we have 1 here, 1 into 2 here, and we have 2 here. OH part we have now 3 into 2, 6 OH we have, and here we have only 2 OH. It's not balanced, right? So let's again multiply this guy with 3. It's not balanced. So let's multiply this guy with 3. Correct. So let's see what you get. So now you get 2H3 PO4 plus 3 calcium hydroxide is equal to 6 HOH plus Ca3PO4. Now let's again see the balance thing. So we have PO4, OH, calcium and hydrogen, and we have reaction and product. So we have PO4 here 2 piece. So we have PO4 2 piece, right? This guy is 2 into 1, this guy is 1 into 2. OH part is 3 into 2, 6. OH part is 6 into 1, 6. Ca part is 3 into 1, 3. Ca part is 1 into 3, 3. Now left with hydrogen. Hydrogen here is 3 into 2, 6. Here 6 into 1, 6. So you see everything is balanced. Thus I can say that this is my balanced chemical reaction. Correct. Now let's take some more example. Here you write a balanced chemical reaction for hydrogen plus chlorine is equal to hydrogen chloride. So we have hydrogen, we have chlorine, both two gases, right? We know that H exists in H2 form, chlorine exists in Cl2 form. This gives HCl. Now it is not balanced, you have to balance it. So the order will be first chlorine and then hydrogen. Correct. So chlorine, if you see there are 2 chlorine items, there are only 1 chlorine item here in product. So let's multiply this guy with 2. So what you get is 2 plus Cl2 is equal to 2HCl. Now let's compare the chlorine and hydrogen part. Chlorine, they are in reactant, they are 2, and product they are 2. Hydrogen reactant 2 and product 2. So if you see that, it is a balanced chemical equation. Easy question. The only thing that you should know that hydrogen is H2 and chlorine is Cl2. We'll take some more examples. We have tried the balanced chemical equation for barium chloride plus aluminum sulfate is equal to barium sulfate plus aluminum chloride. So the equation is like this: barium chloride, aluminum sulfate. So I expect that you know what the formula of aluminum sulfate is equal to barium sulfate. I expect that you know the formula of barium sulfate plus aluminum chloride, AlCl3. These things we already know the formulas of various compounds. These compounds are familiar to us, so we just wrote this formula. Now let's see if it is balanced or not. First, any compound we have, yes, SO4. Then any metal, yes, we have aluminum and barium. Then we have any non-metal, yes, chlorine. These are the four things we have. So let's balance this now. To balance this, first see this is my reactant. Let me write here actually. So I'll use this only actually. So this is my reactant, this is my product. So sulfate we have 3 here and we have 1 here. Correct? This is not balanced, we have to multiply this guy with 3. Correct? There are 3 sulfate, there are 1 sulfate here. So let's multiply. So what you get is barium chloride plus aluminum sulfate is equal to 3 barium sulfate plus aluminum chloride. Now let's again check. So we'll again check that. So we have SO4 here. So sulfate we have 3 here and 3 here. Aluminum we have 2 here and we have only 1 aluminum here. So it's not balanced. So let's multiply this guy with 2. So now what you get is barium chloride plus aluminum sulfate is equal to 3 barium sulfate plus 2 aluminum chloride. Correct? Let's again see it is balanced or not. So we have sulfate, we have aluminum, we have barium. So sulfate we have how many? 3 here and 3 here, balanced. Aluminum we have 2 here, 2 here, balanced. Barium we have 1 here and 3 here. It's not balanced, right? So we have 3 here and we have only 1 here. It's not balanced. So what we'll do, we'll multiply this guy with 3. So what you get is 3BaCl2 plus Al2SO4 3 is equal to 3 barium sulfate plus 2 AlCl3. Now let's again check. So we have SO4, Al, Ba and Cl. Correct? This is my reactant, this is my product. Sulfate part is 3 here and 3 here. Aluminum part is 2 here and 2 here. Barium part is 3 here and 3 here. Chlorine part is 3 into 2, 6 here and 2 into 3, 6 here. So we see that they are all balanced. This guy is my balanced chemical equation. Same thing, the only thing is that they are checking if you know the formula of barium chloride, aluminum sulfate, barium sulfate and aluminum. Thank you. Thanks once again. We'll take one more example. Barium chloride plus potassium sulfate is equal to barium sulfate plus potassium chloride. So we have barium chloride plus potassium sulfate. That gives, potassium chloride plus barium sulfate. This is my formula. I have to balance this now. So here we have any compound, yes, sulfate. That's my first priority. Then we have barium, then potassium, right? And then we have chloride. So let's balance this. So we'll check that sulfate part, if you see, is in both cases we have 1 1, it's balanced. Barium part is again 1 1, balanced, 1 here, 1 here. Potassium part is 2 here and 1 here, so let's multiply this guy with 2. So what you get here is barium chloride plus K2SO4 is equal to 2KCl plus BS. Now let's see the equations. Sulfate part we have 1 here, 1 here, balanced. Barium part we have 1 here, 1 here, balanced. Potassium we have 2 here, 2 here, balanced. Chlorine part we have 2 here and 2 here balanced. So if it is a balanced equation, and that is my answer. Very simple. Calcium hydroxide, that is COOH2, carbon dioxide CO2 gives calcium carbonate CaCO3 plus water. Let's again balance this. So OH part is here, no, it's not there, so there is no compound kind of stuff here. So we'll first take calcium, then carbon, then hydrogen oxide. Correct? Makes sense? So we'll see the calcium part. Calcium part is 1 here, balanced. Carbon part 1 here, 1 here, balanced. Hydrogen part 2 here, balanced. Oxygen part 2 here plus 2, 4 here, and here we have 3 plus 1, 4. So both are balanced. If you see that, this is a balanced equation itself. You don't need to balance. What equation you got is a balanced equation. Zinc plus silver nitrate gives you zinc nitrate plus silver. So if you see, there is an NO3 part here. So first part we'll say NO3. Then metals we have zinc and silver. This is the order of my priority. We'll check first. This guy has 1 nitrate. This guy has 2 nitrates. We'll multiply this guy with 2, right? So what you get is zinc plus 2 AgNO3 gives ZnNO3 2 plus silver. Now let's again check. This is nitrate, silver and zinc. Nitrate we have 2 here, done deal. Silver we have 2 here, 1 here, right? So it is not balanced. Let's multiply with 2. So what you get is zinc plus 2 AgNO3 gives zinc nitrate plus 2 silver. Let's again see the count. So nitrate, silver and zinc. Nitrate is 2 here, balanced. Silver is 2 here, balanced. Zinc is 1 here, balanced, right? So if you see, it's all balanced. Thus I can say that this is my balanced chemical equation. Simple questions only. We have aluminium plus copper chloride. You should know the formula. That's all. CuCl2 gives aluminium chloride AlCl3 plus copper, that is C. Let's balance this. So if you see, this guy has we have metals such as aluminium, copper, and then we have chloride as non-metal. This is my order of priority. Correct? So let's check the aluminium part. Aluminium is 1 here, balanced, right? Copper is 1 here, balanced. Chlorine is 2 here and there is 3. So what I can do is I can multiply this guy by 3 by 2. So what you get here is aluminium plus 3 by 2 copper chloride, aluminium chloride plus copper. So now if you see my equation, aluminium is 1, both side 1. Copper is 3 by 2 here and 1 here. So we'll multiply 3 by 2 here. Right? 3 by 2 and 1. So we'll multiply this guy with 3 by 2. So now what you get is aluminium plus 3 by 2 copper chloride gives aluminium chloride plus 3 by 2 copper. Now let's again check the values. Aluminium, copper and chloride. Cu. So aluminium here is 1, here is 1, balanced. Copper is 3 by 2, balanced. Chlorine here is 3 by 2 into 2, 3. Here we have 3. It's all balanced. Balanced, but in the fraction, so the denominator is 2 here, so we'll multiply with 2. What you get is 2 aluminium plus 3 copper chloride gives aluminium chloride plus 3 copper. And that is my answer. Easy only. Let's take one more example. Write a balanced chemical equation with state symbol for the following equation. Here we have to get the state symbol also. Sodium hydroxide in water, that is NaOH in water, reacts with hydrochloric acid, that is HCl is a liquid, to give sodium chloride solution. So sodium chloride solution is nothing but an aqueous solution in the water plus water. Correct? So this is my equation. And if you see this, it's already balanced equation. Sodium is 1 both side, oxygen is 1 both side, hydrogen is 2 both side, chlorine 1. This is already a balanced equation, and that is my answer. The extra thing is that we have to write the states here. So sodium hydroxide, it was a liquid. Then we have this hydrochloric acid. We got sodium chloride, NaCl, and water as aqueous solution, because the NaCl is dissolved in water, and we got water. Here also we write with symbols. Barium chloride, that is BaCl2, that's aqueous solution, plus sodium sulfate, Na2SO4, that's again a solution, that is the solid actually. Sodium sulfate is a solid thing, reacts with in water. Sodium sulfate is a solid thing in water, so you can say it's an aqueous thing actually, because sodium sulfate is in water, so it's aqueous. It gives an insoluble barium sulfate, so you get barium sulfate, that is a solid because it's insoluble, plus sodium chloride, NaCl. Correct? So we have this barium chloride aqueous solution. Then we have sodium sulfate, is solid actually, and that is put in water, but it's solid, so you can make it solid only. Here's the barium sulfate, that is again solid, insoluble in water, and solution of sodium chloride. So that's what we get. So if you see that is the unbalanced equation, we can just balance it. So here we see that SO4 is there, first priority. Then we can take sodium and barium, and then we can take chlorine part. SO4 1 here already balanced. Sodium 2 here, 1 here not balanced. So we'll balance this by multiplying it by 2. So let's see the equation now. The equation is BaCl2 aqueous with Na2SO4 is again solid, gives BaSO4 solid plus 2 NaCl, that's aqueous. Now again see if it is balanced or not. We have SO4, Na, Ba and Cl. Sulfate is 1 here balanced. Sodium is 2 here balanced. Barium is 1 here balanced. Chlorine is 2 here and 2 here balanced. Right? So it's a balanced chemical equation, and that is my answer. So once we are done with balancing of chemical equation, we know what the chemical equation is, and we also know that the chemical equation has to be balanced, right? And we know how to balance the chemical equation. We had done. Thank you. Good number of exercise for that. Let's see the type of chemical reactions actually. So typically there are 5 types of chemical reaction. The first is combination reaction, decomposition reaction, displacement reaction, double displacement reaction, and combustion reaction. There are 5 kind of chemical reactions we have. There are other types also, but they fall in this type. For example, I'll tell you, typically any chemical equation you can see, by looking at the equation you can say that this is one of the type. Correct? But there are other types of chemical reactions also, that is based on the property. Redox reaction is whether oxidation is going on or reduction is going on. We'll explain this. Acid base reaction, that is whether the reaction is between acid and base. Acid and metal reaction. Exothermic, endothermic, that is whether the reaction is giving out heat or we have to provide heat for the reaction. Precipitation reaction, whether you get precipitations from that reaction. Catalysis reaction, whether catalysis is required or not. Biochemical reactions, organic chemistry reactions, photochemical reactions, solid state reactions, corrosion reaction, ratification reaction. There are so many reactions type, but all of these reactions type will fall into that 5 reactions which I have explained, right? So we'll go through all these kind of reactions. We'll see that all these reactions, right, redox reactions, it can be exothermic redox reactions, it can be any of these, displacement or combination, the five basic types which we talked about in the previous slides, these reactions can be any of those reactions. So basically what I'm trying to say that given any chemical equation or given chemical reaction, it has to be one of those 5 types which we have discussed in the previous slides. So let's discuss those 5 types. The first is the combination reaction. The combination reaction. Before I go for the combination reaction, let me go to the analogy of combination reactions. So the general form of combination reaction is you have 2 chemical A and B. It combines to form chemical AB, and there may be some thing required. For example, heat is required or something. External thing is required, right? Extra condition. But general logic is you have 2 chemicals that combines or synthesize to form AB. So the analogy is there's one guy, there's another guy. There are 2 guys, you can say A and B. Now they both like chemistry subject, and if you see that, they become best buddies. So this is one compound. So there was 2 compound A and B. There were 2 students A and B, and they become one identity. That is, they became best buddies, right? So there was one compound A, one compound B, if you see, and they became best buddies because of the chemistry subject, right? So if you see, there were 2 things and that became one thing. That is the example of synthesis or a combination reaction. Sometimes you need external factor. For example, chemistry subject is one external factor we have that made these guys best buddies. Sometimes even that is not required. They just become best buddies. So in the form of chemistry, again, we'll touch upon this definition of the same reaction, combination and chemical reaction. We'll see this concept from a chemistry lens. So we have 2 elements that combines to becomes AB. So the description is 2 chemical species combine to become a single compound, right? So we have 2 chemical species they become a single compound. That is example of a combination reaction. For example, you have a quicklime and you add water to it, it becomes shake lime. So if you see, there are 2 elements here. One was a quicklime, one was the water, and it combined to become a shake lime. That is, CaO was my quicklime, the solid. You give water to it, it becomes COOH2 plus aqueous. And if you see, this guy gives heat also, right? It gives heat. So this is an exothermic reaction. So this is one of the reactions which you'll learn now, I mean, after some 10-20 slides. But what I'm trying to say is that this reaction is also another type of reaction also. For example, this chemical reaction, this synthesis or combination reaction can be a reaction also. So we have hydrogen plus oxygen. You combine these 2 molecules, you get water. So you have hydrogen gas, oxygen gas. You combine this, you get water. So you have 2 products, you get 1 product. So we have sodium and chlorine. You add these 2, you get sodium chloride. So you have sodium and chlorine. One was sodium was solid, chlorine was gas. You get NaCl, that is again solid. So you have magnesium and oxygen. You add these 2, you get magnesium oxide. This we have done actually. So you heat this. So you have this magnesium ribbon. So you heat this in presence of oxygen, you get magnesium oxide. This is also one combination reaction. We have 2 elements you combine to get a single element. You have carbon monoxide and you have oxygen. You again heat this guy, right? So you get carbon dioxide. So that's again a combination reaction because you have 2 products and you got a single product as an output. So one more example, you have sulfur dioxide and oxygen. You combine these 2, you get sulfur dioxide and oxygen, you get SO3, that is a gas. So these are some examples of the chemical reaction which are combination chemical reactions or synthesis chemical reaction. The point here is that in all these reactions we have 2 products, you get 1 product out. We have 2 products, 1 output. 2 products, you get 1 output. You have 2 inputs, you get 1 output. So the reactant part has 2 items and the product part has 1 item. That's the example of synthesis chemical reaction. Let's do an activity for that. So what I can do is we can take some amount of calcium oxide or quicklime in a beaker. So this is a beaker and we have taken some lime in this. Slowly add some water to it. Let's add some water. If you see, right, this thing got dissolved. This thing got dissolved, right? So if you see, The moment we add water, this thing got dissolved. And now let's touch the beaker. And what you will notice that it's hot. This is hot. So what has happened here? So we have this CaO, the line we have, quick line. On this we added water. This gave aqueous solution. This is the aqueous solution actually with the CaO, and it gave heat also. So if you see, two items became one item, right? And this is an example of my synthesis chemical reaction. Correct? So where we have two inputs, A and B, it gives you a new output called AB. One put. The next is decomposition reaction. Let's study the analogy of this. So they were two best buddies, now they're just one identity, two best buddies, and they fought over some topic. I don't know, maybe they got less, one got less marks, something. They just fought, and now they are two different people. So they were one identity called best buddies. They fought in the real life, right? They fought and they became two different identities. This is similar to what we have a decomposition chemical reaction in the chemistry world. So we have this one compound AB, you decompose to becomes two compound. So the description says a single compound decomposes to become two or more chemical species. It may be more also, it can be C and D also. The concept here is one compound and then breaks into multiple compounds. So for example, you have water, you pass some electricity to that, and that becomes hydrogen and oxygen. So on electrolysis, so this is, I think, electrolysis, this water is a one compound breaks into two smaller compounds. Use hydrogen peroxide again, that is converted to hydrogen water when you pass something. We have copper carbonate, they can heat, I think you heat this guy, it becomes copper oxide and carbon dioxide. You have ammonia, you can convert this to nitrogen and hydrogen. So one compound into two small compounds. So you have nitrogen triide, you can convert into nitrogen and iodine. So these are the chemical reactions where you see the common thing is you have one big compound and this got combined into smaller species. This is an example of decomposition of chemical reaction. Correct. For activity, what we can do is we can take 2 grams of ferrous sulfate crystals in a dry boiling tube. So this guy is a boiling tube. Here I have ferrous sulfate, right? 2 grams. We note the color is blue. Now heat this over a burner. So let's heat this over a burner. But we'll observe that this color changes to red, right? So we'll observe that the color change to red. Also we'll see the pungent smell. The smell comes out, right? This is the nose we have. Smell comes out. There are two things. One thing is the color change and you get the smell. So if you see, this was my original compound and this is my new compound, right? This is my new, this is my old compound. So what do you see? What happened here? This guy was my ferrous sulfate. This is the blue one. When we heated this guy converted to Fe2O3. You got this gas also, and this gas is nothing but a pungent gas which you got. So in this, if you see, one compound is converted to multiple small compounds. This is a typical example of a decomposition chemical reaction where bigger compound is decomposed into smaller compounds. We'll take a more activity. So we take some 2 grams of silver chloride. This is a silver chloride. And we'll note the color. We'll put this in the sun for some time. So we'll have a stopwatch. Maybe after 1 hour we see that. We see that the color changes. It was white, it became gray, right? So let's see the color changes. Why the color changed? Because if you see now, earlier it was AgCl, silver chloride. On sunlight, this broke into silver and chlorine. This is the silver now, and we got chlorine gas. The gas evaporated. So if you see, this compound broke into 2 smaller compounds. And this is also one example of decomposition. The analogy of displacement reaction, the scenario which we have in real life, which is almost similar to displacement chemical reaction in real life. So there we have one compound AB, another compound C comes and it displaces this B, and the B comes out. That's how it is. So there's a compound AB, they're happy together. One guy comes C, and C displaces this guy because A is attracted more towards B, or something happens, right? You apply some heat to something, so this becomes AC plus B. For example, in the real life, let this guy be A, who is dancing happily with his partner, and the partner is B, right? So they're happily dancing. Now the instructor sees one more girl come, and she's also a good dancer. Now the instructor sings, but nothing happens, right? So they are happily dancing. One more person C has come. The person C has come, but nothing happens. Or maybe the moment the person has comes, this thing got displayed. Or the external factor is required. The external factor is supposed to be instructor. Instructor says that, dude, this lady is wearing a red dress and you are wearing a blue. It won't look good in the stage. So why don't you swap? Why don't you swap? So then what happens? This lady swaps with this girl, and this girl comes out here. So if you see now, earlier A and B were dancing together. There's one new girl who came in C. The instructor told that the dress looks better, the blue and blue. So why don't we dance together? So now if you see, this guy is A and C. Now A and C are dancing, and the B lady who was here, now B lady is out. Right? It may be that A likes to dance with C. It may happen that you don't even need instructor here. The moment C comes, B tells no, I don't want. A tells to B, I don't want to dance with you because you're wearing a red dress. I want to dance with C. Maybe this guy himself tells, because maybe that this guy is inclined toward this lady, or maybe this guy is not inclined that much, but the instructor forced him to do it. So maybe this reaction happens on its own, or maybe happen on some external force, for example, heat or temperature, or temperature or pressure or something, or some catalyst also, right? So some catalyst also may be required for this. So, but end of the day, you forget this part, you exclude this part to make it life simple. But end of the day, what's happening is A and B were dancing, C came, and now A and C are dancing, and the B is gone, right? So this person C took the place of B, and the B is out now. Correct? This may happen in the real life scenario when you're practicing dance in schools, and the teacher tells that no, this pair doesn't look good, let's change the pair, right? So that's one example of a displacement chemical reaction in our daily life. So let's see the chemistry definition of this displacement chemical reaction. You have this product AB. When C comes, C displaces this guy B, so it becomes AC, and the B is out. So it says that one element or ions moves out of one compound and into another. One example is active acid plus active metals. You get this kind of reaction. This is one example of that. So we'll take more examples. So you have hydrochloric acid and magnesium. If you add, so you have hydrochloric acid and magnesium. What you get is MgCl2 and H2. So what you have seen this Mg, it came here and it paired with Cl, and hydrogen is kicked out. Correct? Sulfuric acid plus iron is equal to iron sulfur plus hydrogen. So here if you see, iron came here, it kicked out hydrogen, and hydrogen is an independent identity now. Correct? Fe kicked out hydrogen and it become FeSO4. Here if you see, nitric acid plus magnesium, nitrogen, hydrogen. So we have nitric acid HNO3 plus magnesium, it gives magnesium, nitrogen, and hydrogen. So if you see, the magnesium came here, kicked out hydrogen, and the hydrogen is out, right? And magnesium and nitrate become magnesium nitrate. Zinc you add with hydrochloric acid, this becomes zinc, chloride, and hydrogen. Zinc and hydrochloric acid, if you see, the zinc guy overtake this guy HCl, hydrogen is kicked out, and this guy is out. So in this, if you see, this happened because zinc wants to gel up with chlorine more, right, than hydrogen. So zinc has a more affinity to gel up with chlorine than hydrogen, and then then it pairs, creates a bond with chlorine and the hydrogen is taken out. So we'll understand all these things I think in the class 11 when we discuss the atoms, the shape of atoms and how they have neutrons, protons and electrons and what makes it stable and why this reaction happens, right? So all these things we'll study in class 11, the reason behind this reaction, why it's happening. You must be wondering, right? But when you add zinc and hydrochloric acid, why it becomes reactant? This answer to this, but now it will be too difficult for you guys to understand because in class 10th now. Once you move to class 11th, we'll understand why this thing happens, because zinc has more affinity to attach with chlorine than hydrogen, so that's the reason why it happens, right? So we'll learn all the things in class 11, but just for now you can understand that this is a kind of displacement chemical reaction where one element displaces another. So here also lead plus sulfuric acid becomes lead plus sulfate plus hydrogen. This guy lead kicked out hydrogen and hydrogen is out now and this becomes lead sulfate. So this is one example of displacement chemical reaction, right? So for this we'll do an activity. So we'll take 2 iron nail and 2 test tubes marked A and B, and in each test tube take 10 ml of copper sulfate solution. So we have 2 iron, 2 test tubes, right? And this is going to be A and B, and both has copper sulfate solution. Immerse 1 nail in copper sulfate solution for in test tube B for 20 minutes. So in test tube B will immerse this nail. In test tube A won't immerse. And will this keep for this 20 minutes. And after 20 minutes, it would take out this nail from this test tube B, right? Please note, test tube A we are not even touching, that's just for show. We'll compare this later. Test tube B is something which we are doing stuffs now. So test tube B we have put this for 20 minutes. It's all copper sulfate solution, right? Now after 20 minutes take out this guy nail. So we'll see that after 20 minutes the color change. The color of copper sulfate also change and the color of nail also change. And we'll take out this guy after 20 minutes. Now compare the intensity of the blue color of copper sulfate solution. If you see, this guy is dark now and this guy is light. Both are copper sulfate, but this guy become lighter. And also if you see if you compare the nails also, they are different. There's more blackish now, right? So both has changed. The nail color has changed and the copper sulfate solution has changed. What has happened? What has happened is you had this iron that is the nail. In this you dipped with copper. You dipped this guy in copper sulfate solution. What you got is FeSO4. So now this guy is FeSO4, right? And this guy is a little copperish. This is not black actually. This guy should be a little copperish color. So this guy is a copper. This guy is a copper. This guy got a layer of copper here, right? So this guy is a copperish color, and this should not be black. There's some issue with the animation. This guy should be a little copperish color, and this guy becomes a lighter color because FeSO4 is lighter and CuSO4 is darker. So that's how it happened. This CuSO4 become FeSO4 and this iron got a layer of copper. Thank you. We'll understand analogy of double displacement chemical reaction. So till now we have done 3. This is the 4th kind of chemical reaction, double displacement reaction. So here there are 2 pairs, AB and CD, and they swap the pairs. So this becomes AC and this becomes BD. So we'll see how it is. So for example, this is one guy and one girl, and this is one guy and one girl. If you see, this is A is a girl in red, B is a guy in blue, C is a girl in blue, and D is a guy in red. And they want to create a dance pair. They say that I am one dance pair 1 and I am pair 2. They are 2 dance pair, right? So they are 2 elements actually. They are 2 elements. They are together. This is one dance pair and this guy is one dance pair. Now again the instructor came and told that no man, it doesn't look good. Red should pair with red and blue should pair with blue. So now they are like this. Now if you see, this guy was A and the red guy was D, right? The blue guy was B and the blue lady, sorry, this is C, and blue lady was C. So if you see now, from AB plus CD it becomes AD and BC. You see, right? They swapped actually, right? They swapped. So it was AB and was CD. They swapped. It can be any swap. This is swapped. And these kind of reactions are called double displacement chemical reaction. So here I wrote AC and BD. I could have also written AD plus BC. doesn't matter because anyway we are going for a swap, right? So in this case it is AD and BC. It swapped the condition called instructor. This is something that happens in real life, right? So we form pair, and then our dance teacher says, no, this pair doesn't look good, let's swap, and we swap our partners. So that's one example of a double displacement chemical reaction where both are swapped, not only one. So let's understand the double displacement reaction from a chemistry perspective. The formula still holds same, AB plus CD is equal to AC plus BD, or it can be other way around. It can be AD plus BC, that this guy pairs and this guy pairs, right? So any of this is fine. So here the exchange of ion happens. An example is precipitation acid-base reaction. So we'll explain what are these reactions later. So some examples are, if you have this HCl hydrochloric acid and sodium hydroxide, you add this, becomes sodium chloride, NaCl, and water. So if you see this guy H forms pair with OH, right? HOH, and Cl and Na forms a pair, NaCl. So the one in square forms a pair and the one in circle forms a pair. Here also if you see Ag and Cl, both are in circle, they form a pair, AgCl, and the one are in square, that forms a pair, NaNO3. If you see, they form a pair, NaNO3, and this is circle, right? Similarly, we have this BaOH2 and this CuCNS. This becomes, you see, Ba and CNS forms a pair, and Cu and OH forms a pair, right? So this guy and OH2 forms a pair. So you get this kind of equations. Here FeS and HCl. So if you see there, in this case, Fe and Cl forms a pair, and H and S forms a pair. So that's what you get. So this is the example where you have double displacement things happen, right? So hope you understand the concept of double displacement, that both the things are displaced. We'll take some activity for this. We'll take 3 ml of sodium sulfate solution test tube, and another test tube will take 3 ml of barium chloride solution. We'll mix both. So we have, in this case, we have sodium sulfate, and in this case we have, Na2SO4, and barium chloride we have in this. So we'll mix both and we'll observe that this guy gets a precipitation of sodium chloride. You see this white color thing, right? That guy is nothing but NaCl. So you get a precipitation of NaCl, sodium chloride, and this blue color, what you get is nothing but BaSO4 solution. So when you mix this, you got some precipitation and you got this solution also. And this is the reaction that happens. Na2SO4 plus BaCl2 gives BaSO4 plus NaCl. In this case, if you see sodium and chlorine, they form a pair, correct? They got NaCl. And the sulfate and barium form a pair, got barium sulfate. And that's what happened. So this is one of the activity to observe this double displacement chemical reaction. Now we'll discuss the last type of reaction called combustion reaction. So anything you burn, actually, there's nothing but combustion reactions. You have your diesel, you burn your diesel, you have some food, you burn it, you have wood, you burn it. Those kind of reactions when you burn something, that is nothing but a combustion reaction actually. So if you see, the thing that happened is you burn something, you have some eggs, you burn that, you get some carbon dioxide and water. This is a typical example of a combustion reaction. Burn anything, you get stuff, that is combustion reaction. Thank you. Discuss the other types of chemical reactions which we have taught, and please remember that these type of chemical reactions will be part of those 5 major types, right? So there are the 5 major types, but these will also be, these are just the reaction based on the property. So other reactions which we have was based on the number of inputs and outputs. For example, in one case, the decomposition happens, right? So one item got into 2 items. In synthesis, we have 2 items, you make it AB, right? So this was the decomposition, this was synthesis, and then you have this displacement reaction. You have AB, you added C, this becomes AC and B. Then you had this double displacement reaction. You have AB and CD, this becomes AC and BD, right? So those, and then you have combustion reaction. So These were the reactions which in the major classification. These precipitation reaction is nothing but a reaction where you have two solutions, you get a precipitation of insoluble C also and a solution D. So generally in maximum case, this precipitation reaction is nothing but a double displacement reaction. It's a type of double displacement reaction. In 99% case, this precipitation reaction is nothing but an example of double displacement reaction. So you have two solutions, you mix, you get one insoluble substance, that is nothing but a precipitation of that in one solution. Correct? So that's what the chemistry description says. In this precipitation reaction, two solutions are mixed together. It forms an insoluble solid, and that is nothing but the precipitate. It's a type of double displacement reaction itself. So when I'm discussing about precipitations, let's discuss solubility also, because they are all linked together. So things can be soluble, it can be moderately soluble, and it can be insoluble, right? So for example, so if you mix milk and water, they are soluble, right? You can't separate them. Moderately soluble, that you have some sodium chloride and you mix with water, they are soluble, but after some time, if you still find some crystals of that. Sugar, if you add with water, right, you'll still find some crystals of sugar. Or if you have this chocolate coffee, you add with you make chocolate shake, right? So chocolate shake, you make chocolate and you add with milk. When you prepare the chocolate shake, things looks fine, but after some time, right, this precipitate down. They're moderately soluble. Insoluble is it won't even mix. For example, you take iron nails and you try to mix with water. It won't even mix. You do anything, it won't even mix. Those things are insoluble. And these things are nothing but the property of the substance, right? So the solubility is nothing but the physical property of the substance, and that depends on a lot of factors, how it is structured, and those kind of stuffs we'll study later classes. These scientists have observed a lot of things, and they have come to some generalization rules about the solubility of certain substance. The thing they observed was solubility also depends on the temperature. In most of the cases, solubility increases with temperature. If you see, if you add sugar to water, you see that sometimes it is not, you're not able to mix it. But if you warm it, you see that you're able to mix it properly, right? This is a real scenario. In your kitchen also you can do this. So you mix some sugar with water, you'll see that you need to churn it properly, right? You need to put some effort to mix it. But the moment you warm it, everything is mixed. So in warm water, things get soluble easily. Same thing with you have this Horlicks and the Complan you mix in cold water, is not that easy to mix, but the water is warm, it's easy to mix. So the solubility depends on temperature in general case. It increases with the temperature. For example, so when you talk about solubility, you don't talk only about the substance, because it depends on the substance, but you also talk about the temperature. So you say potassium nitrate has a solubility of 31.2 gram per 100 gram of water at 20 degrees Celsius. That means if the water is 20 degrees Celsius, you can mix completely this 31.2 gram of potassium nitrate in 100 gram of water. Thus, you can say that solubility depends on two factors. One is the property of the substance, and then it is depending on temperature as well. So a solution that contains maximum amount of dissolved solid is called saturated. For example, if I take 100 gram of water and I dissolve this much gram of potassium nitrate, I call this guy as a saturated thing. But now what happens is, if this is saturated now, and I cool it, I make it, let's suppose 5 degrees Celsius. Now at 5 degrees Celsius, this guy can hold, let's suppose 25 grams only, right? Now what happens is, the extra 6.2 grams, it will come out. It will come out, and that will be a solid. And this process is nothing called recrystallization or precipitation also, you can see, right? So that is nothing but we are looking for, right? So we have a solution which has some crystals and they are saturated. Now you decrease the temperature of this. So whatever, since you decrease the temperature, this water can't hold those many crystals. Those things will come out, and that is nothing but recrystallization. So all things are linked actually: precipitation, recrystallization, solubility. So I thought it's better to have a slide on this, and you guys should understand what is happening. The real reason behind everything is that a substance can hold a certain amount of salt at a certain temperature. The more you reduce the temperature, this thing comes out, right? So the extra gram of salt which it can't hold, it can't bear, it is crystallized and comes out. And that is nothing but the process of crystallization. Discuss the acid-base reactions, another type of reactions, acid-base reactions. And please note, this also will come in one of the five, the basic properties, the basic classification of the chemical reaction. It will come in one of those five, depending on the reaction I'm talking about. So general form is acid plus base is equal to salt plus water. So since it is acid plus base equal to salt plus water, so it is like, reactants of a base and the acids, they react and the product is salt and water, right? So the positive ion of hydrogen of the acid and the negative of this hydroxyl ions, they lose electrical charge and becomes covalent molecular with the water. So you don't understand this line, you can forget this line now. You'll understand this more when you learn the covalent bond thing. Just understand in acid base what happened is you have this reactants of the acids and base, and the product is salt and water. And generally it is a double displacement reaction. Generally, in case it's a double displacement reaction. And so acid base reaction actually is nothing but a neutralization reaction, because what you're doing is you have a acid, you have a base, and finally you're getting the solid, it's neutral, right? So it's also called a neutralization reaction. Both are same. You tell acid base reaction, your neutralization reaction, both are same actually. For example, I'll take one example. You have hydrochloric acid as an acid, plus you take a base NaOH. You know that base has OH, and if you don't know, next chapter we are going to, next chapter will go for as acid and base. So you have acid and base, you react, you get NaCl as a salt plus water. This is a typical acid base reaction, and if you see here, the chlorine is pairing up with Na to get NaCl, and H is pairing with OH to get water, right? H2O. Water is H2O. This is a typical double displacement reaction where you have acid and base, they combine to form a salt, and also called a neutralization reaction. Now we'll talk about exothermic and endothermic reaction. So it all depends on the heat. So if it gives out heat, it's exothermic. If it takes hits, it's a endothermic reaction, right? So if heat is given out, it is exothermic, and if the heat is absorbed, right, energy is absorbed, it is an endothermic. So for example, so we have this magnesium and we have oxygen, you heat it, right? You heat it, so you get magnesium oxide. So in this case, the heat was required, right? So it is a endothermic reaction. But if you see a reaction, combustion reaction, for example, you have any substance, or you have this lime water, you have COO, you add with water or carbon dioxide, I think, right? So you get CaCO3 plus heat, right? So in this case, if you see, this guy is giving out heat, so it's an exothermic reaction. So you can see that this is a different classification altogether. So these also fall in one of these five. So it may happen that you get a combustion reaction as exothermic. You also may get a synthesis reaction as exothermic. You may get a this kind of decomposition reaction as exothermic. You may also get a replacement or double displacement reaction also as a exothermic reaction. Similarly, the case with endothermic. So This classification is not based on the product numbers and the replacement it makes. This is solely based on the heat. If it emits heat, it is exothermic. If it requires heat, it is endothermic. Right? But end of the day, typically it will be part of one of these reactions, and it depends on the equation I'm talking about. Right? You can't say that all the exothermic reactions are decomposition reactions or synthesis reaction or double dipping reaction. It can be any of these depending on the equation I'm looking for. But this is a different classification. If it takes heat, exothermic. Sorry, if it takes heat, it's an endothermic. If it emits heat, it's an exothermic reaction. Now the question is, why is respiration considered as exothermic reaction? So in the exothermic reaction, if you see, we have the heat is given out, and we see that in respiration what happened is we have this food, oxygen is taken, with this we get energy and we get heat. Right? This is the typical example of the or typical equation for this respiration. In this case, if you see, the heat is coming out. Since the heat is coming out, this guy is an exothermic reaction. Hope you understand this. In case of respirations, you have this food in presence of oxygen, the body using some catalyst and enzymes, right? So this guy produces energy and heat. It comes out of this reaction. So it's an exothermic reaction. Now we'll understand redox reaction, nothing but oxidation and reduction reaction. It's a very critical reaction. So reaction that involves loss or gain of hydrogen is called redox reaction. So if you are gaining oxygen, gain of oxygen or loss of hydrogen, that is oxidation. You are losing oxygen or gaining hydrogen, that is reduction, right? So you gain oxygen. So if you're gaining oxygen or losing hydrogen, it's oxidation. So oxidation means gain oxygen. Reduction means lose oxygen. Correct? So for example, if you have this copper, you have oxygen, you heat this copper, right? In terms of oxygen, it becomes COO. So in this case, if you see, the copper is gaining oxidation, oxygen. So you can say that copper is oxidized. Again, this copper you again heat in the presence of hydrogen now. So if now again see, the copper is losing electron, losing oxygen. So in this case, you see, the copper is reduced and hydrogen is gaining oxygen now, right? Hydrogen was H2, it becomes H2O. We can say that hydrogen is oxidized. Correct? So anything that gains electron, gains oxygen is oxidized. In this case, copper is oxidized. Here hydrogen was gaining oxygen, hydrogen oxidized. Anything that loses oxygen is called the reduction force. In this case, the copper lost oxygen. Same thing for hydrogen. If something loses hydrogen, that is oxidized. Something gains hydrogen, that is reduced. We'll study all this reaction in the later chapter more in deep. Corrosion is an example of a redox reaction in daily life where this things you see is it gets corroded, right? So it was a good looking object and this thing became rusted. So what happens in corrosion is and the question is, why do you apply paints in an article? Because we don't want this iron to come in touch with oxygen. So what happens is you have this iron, it comes in oxygen, this gives a reaction, it's called Fe2O3, and that is nothing but rust, which you see here. To avoid this oxygen, we paint this. So if you avoid this oxygen, if you paint this, the iron won't come into contact with oxygen and this Fe2O3 won't be created, and then the resting will be provided. And why this is happening? This is the redox reaction. Why? Because the iron is gaining oxygen. So iron is oxidized here. Correct? So we'll study more in deep about oxidation and reduction in class 11. Just in this chapter, the concept was to make you understand the 5 basic type of reactions we have, right? And other reactions we should generally use, for example, redox reaction, acid-base reactions. One ratification reaction is also one example of redox reaction in real life. So if you see the food which you have, which you keep in some time in dry place, it gets a bad smell. Why a bad smell? Because this guy has fat and oil, right? This thing get oxidized and they become rancid and their taste is very bad. This is one example of redox reaction in daily life, right? And that's why what we do is we keep this food in an airtight container, right? And also if you see the chips which you get, the chips, Uncle Chips and Lay's and all the chips you get, they are packed in this wrapper and they are all airtight. And this inside that they put some nitrogen so that they don't come in contact with oxygen, and these prevent these things to get oxidized. Because if it's oxidized, it gets spoiled first. If you see the pickle also we have in homes, right, that is dipped in oil. So this pickles which we have is really dipped in oil. Why? Because in oil, if it is an oil, it won't get contact with oxygen. If you don't get contact with oxygen, it won't get rancified and it won't get spoiled, right? So that's one way to prevent these things from getting rancified. So what we have learned the chemical equation definition, that it represents reactant, product and the physical state symbolically, and the chemical equation has to be balanced always, right? The law of conservation of mass. So in combination reaction we have two or more substances to form a single composition. In decomposition reaction we have one compound bringing two or more substance. So in displacement reaction we have one element displace another one. In double displacement we have both the elements swap, right? And the reaction where heat is given out is called exothermic. The reaction where requires heat is called endothermic, right? This we have learned. We have learned the oxidation is nothing but the process of gaining of oxygen or losing hydrogen, and reduction is the reverse process of losing oxygen or gaining of hydrogen. That's what we have. Thank you.